Hey, what's up, Mr. Suda here. Today we're going to be talking about energy transformations. Now, a little recap of energy. Remember, we have two types of energy. We have either potential energy or we have kinetic energy. Now, energy can also take many other different forms, such as we could have chemical potential energy in the form of rocket fuel, or we could have potential mechanical energy in the form of a stretched rubber band that's elastic potential energy. We could have kinetic energy in the form of sound. We could have kinetic energy in the form of radiant light. Right, now remember there are many different forms of energy. The main ones we're going to focus on are chemical energy, electrical, radiant, that's light energy, mechanical energy, thermal, and nuclear energy. Alright, so what are energy transformations? An energy transformation is a change in energy from one form of energy to another form of energy. Now remember, energy cannot be created or destroyed. It only changes form. Remember, that's our law of conservation of energy. And the total amount of energy is always going to stay the same. So because energy can't be created or destroyed, it has to just change from one form to another. Right, so we have this biker. He's biking up the hill. He puts energy in, and he also has to get some energy out. So he's changing from kinetic energy to potential energy, and then back to kinetic energy on the other side of the hill. Here's another example of an energy transformation. So our sun has nuclear energy. It turns that nuclear energy into light energy. Light energy can then be turned into heat energy in the atmosphere, which warms our Earth. That light energy can also be used by trees during photosynthesis to produce chemical potential energy. And then when people eat those plants, they can get heat energy to warm their bodies, or they can use that energy from the plants as mechanical energy to move. All right, so question here. If energy can't be created or destroyed, then why doesn't my phone stay charged forever? The answer, in every energy transformation, some of the energy is lost to the surrounding area as heat energy. So your phone is constantly losing energy, mostly as heat energy. Once all the stored chemical energy of the battery in the phone has been used, the phone doesn't have any more energy to transform and the battery has to be recharged. So here's an example of our phone battery here. So we're putting input energy. That's the chemical potential energy from my phone. And when I use it, I get some useful energy out of it. That's when my screen lights up and I can see all of the different screens on my phone, whether I want to open up some different apps. That's what we want on the screen. We want the screen to light up. We want to be able to form the communications on our cell phone. However, at the same time, not all of the energy is turned into useful energy that powers your phone. Most of the energy is going to be lost as actually all the energy eventually is going to be lost as heat energy. So if you have your phone and you've used it for a really, really long time, maybe you were watching a movie and you feel the back of your phone, it's been going on for a long while, it might feel hot. That's because some of the energy is lost as heat. And your phone will continue to use its energy from its battery to use that to turn into useful work energy until all of the energy from the battery has eventually been lost as heat. And once all the energy is gone from the battery, there's no more chemical potential energy, and you have to recharge your phone. I wish it'd stay powered forever. I wish it would stay powered forever, but unfortunately, it doesn't. All right, now you can think of the energy lost to heat as like the bad guy, and he's stealing some of the energy in the conversion. So our conversions aren't always perfect because heat's always going to want to steal some of our energy. Right, so here are natural energy transformations. So here's an example. We have our sun has radiant energy, which can then be converted into chemical energy by plants through the process of photosynthesis. So trees are using this chemical energy to grow, and then we can use this energy as something called biomass. So biomass just means plants. So we take our tree here and we chop it up into wood chips. We can then light those wood chips on fire in a boiler. We use that boiler to boil water to create steam. That steam then turns a turbine and a generator, which produces electricity. The electricity runs through the power lines here into your outlet in your house. That's how we go from energy from the sun to energy in your outlet. All right, so here are some more examples of energy transformations. So a car driving down the street is transforming chemical energy in the gas tank to mechanical energy through the motion of the car. So that's chemical to mechanical energy. We could have chemical energy in a battery being transformed to mechanical energy. So for example, the motion of a toy. So chemical potential energy in the battery turning into mechanical energy when the toy moves. Some more examples of energy transformations. The chemical energy in wood being transferred into thermal energy as fire. We have chemical energy in an apple being transformed into mechanical energy when running. So you eat the apple and you're turning the chemical energy stored in the apple into useful energy, which you can use to run, which is mechanical energy. So energy transformations can also be multi-stepped. When the energy transformation is multi-step, that's called an energy chain. So for example, in a hairdryer, we have electrical energy from our wall. That electrical energy turns into mechanical energy, which spins a turbine, which then can convert it into thermal energy, which makes the air warm that passes through it. In a flashlight, we have chemical potential energy from a battery, which is then turned into electrical energy in the wiring. And then from there, the electrical energy is turned into radiant light energy at the light bulb. An example here, we have a wind turbine with a light bulb. So we're going to see how we can go from wind, how wind can then light up a light bulb. So we have a big gust of wind. The wind moves the fan blades, which spins the turbine inside of the fan's housing. The movement of the turbine powers the generator. The generator can then send electricity out to an external place to hold that energy. And that electricity runs through, and then it can power our light bulb and turn into radiant energy. So we went from mechanical energy from the wind to mechanical energy when the turbine inside the fan was spinning, to electrical energy in the generator, and then to radiant light energy when the light bulb turned on. All right, so try this one out. So what energy transformations occur when you boil a pot of water on an electric stove? So pause the video here, and I want you to think about this question here. When you're ready, unpause the video, and I'll talk about it a little bit. All right, welcome back. So let's look at this example. So what's going to happen when you boil a pot of water on the stove? What energy transformations occur? So first, we have electrical energy from the wall. That electrical energy is then used by the stove to create thermal and light energy on our heater elements. And then from there, that thermal and light energy from the heat element is turned into thermal energy, which is stored or being transferred from the element into the water. Now you can see here, we still had thermal energy, but we were moving from the thermal energy from it being on the element to the thermal energy being in the water or being stored by the water. Right? That's going to wrap it up for energy conversions. I hope you learned something, and I'll see you in the next video.